Hello, my name is Andres Marone, and I partnered up with Anthony Galvan to do this engineering project. We were confronted with the mechanical engineering problem, which relates to statics. So I'm going to pull up the problem right here just to briefly describe what our code is meant to do. So what our code does is that it gathers information from an Excel sheet, and this information is a bunch of different values uh, corresponding to the length, different values for length of AB, different values for length of cable BC, and um, and the weight of W. So what our code does is that it outputs the tension between AB, the tension for cable BC, and the different angles that they make regarding to the ceiling. So before I get started, I'm going to show y'all that our Excel sheet is saved onto the same folder that our um, script and that our function are saved on. So first line is that it data equals XLS read our Excel sheet. So this allows MATLAB to store and basically gather all our information from our Excel sheet. After that, we're going to find the number of rows and the number of columns using the size function, the built-in size function for MATLAB with respect to our data, which was defined up here. After that, so we have 15 trials, so rows equals 15, and we have 1, 2, 3, 4, 5 columns. Sorry. Um, After that, we find the number of elements by multiplying our number of rows and columns. So our first for loop, what it does, it goes through each element and it sees whether or not it's less than 0. If it's less than 0, it's going to fprintf this statement. One or more of your loaded data values are negative. The absolute value of that negative data was taken. So once it finds a negative value, we use the absolute built-in function to correct it. In other words, no. So if we find a negative value, we take absolute value, and that we assign it to that new. We assign it again to that, and we basically fix the problem. Uh, After that, we define all these variables. So we tell MATLAB that D is equal to data all rows second column. So as you can see, D is equal to all rows second column. W is equal to data all rows third column, as you can see again, and so on for the rest of them. Our task 2 goes through each length AB and compares it to its corresponding length D, and it see if it's greater than that. If it's greater, then it's going to fprintf this statement. One or more of your length AB data values was larger than its corresponding length D. Make this value less than blah, 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 and greater than blah, blah, blah. And we fprintf those values. After that, we let the user correct the mistake. No? So if length AB was greater than D, we let the user input a value that's, again, less than blah, 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 and greater than blah, blah, blah. And that's what we did over here. And we assign it again to length AB. After that, we make placeholders for our angle theta, length BC, and the tensions. We do this so that once we run our function down here, our outputs have a place to go. So by creating this this matrix of zeros, well, once we define them, they can be stored into that, and then we'll have, a matrix of our values for theta, a matrix for our values of tension AB, and so on. So task 3 is where we call onto our function. So z equals another for loop. So we're going to start at 1, and we're going to run this 15 times because, again, 15 is the number of rows that we have. So 15 trials. And our outputs are going to be theta, tension AB, tension BC, length BC, and phi. And our inputs are DZ, length AB, X, and our weight W. So now we go over to our function. And here are all the calculations. So again, the outputs are over here listed, and the inputs are over here listed. And very complicated math equations. And before we could do any of these equations, we had to look at uh, how we could use arc, or the inverse of cosine, in degrees in MATLAB. And it turns out that MATLAB is it already has that built-in function, which is right here for an example. So A cosine D, and that means arc cosine in degrees. So we use that a couple times. For example, we use it here. We use it again down here. For example, we only use sine in degrees here and tangent in degrees. And we use those functions a lot, honestly, for this problem. So then our next step is to display our values, our outputs from the function. So fprintf, the value for each trial, r, and we made a nice little table. So trial number is one column, theta is going to be one column, tension AB, and then tension BC, all separated by two tabs, as you can see. And then we go down here and we're going to do another for loop. So we're going to run this 15 times, or the number of rows, and we're going to fprintf the number of trials goes here. What was it? Theta goes here, length AB goes here. Oh no, tension AB goes here, and tension BC goes here. And here are our respected variables that are going to be fprint, that are going to be displayed. No? And then our task 4 is to rearrange the values. You will plot from smallest to largest. So what we did was use the function sort. And what this does is it sorts it from least to greatest. So pretty easy. We just sort LBC and we assign it to the new LBC. Do the same thing for tension AB, tension BC, and assign it to the new ones. After that, we're going to plot the calculated tensions and angle with respect to incrementing length BC. So another for loop, because we're going to run this for how many number of trials we have, and we're going to have however many number of figures. So here we go. We plot all this, more complicated math equations, and we find the polyfit of each one, and we find the slope of it and the the y-intercept, and we do the same thing again. So this is for, I believe, cable AB, and this one's for cable BC. And then this is where we actually plot them. So this is actually where we plot AB. This is where we plot cable BC, and we give them, nice colors to be able to distinguish them. So AB is going to be blue and BC is going to be green. And then we label our x-axis, y-axis, our tidal, and we put on our grid. Down here is where we plot our ceiling, so line D. And we gave that a nice solid black color just so you can distinguish it well. And then we end it. So we're going to plot all 15 of them, and we're going to go down here, and then our last lines of code is to find the max length of BC. So we did that by assigning it to this variable. Max length of BC is equal to max, which is just the MATLAB built-in function of LBC. But LBC was already, sorted from least to greatest. And then we do an F statement. The maximum length of BC is blah, blah, blah feet. And here is our variable, which goes back to over here. So for this part, what we did actually to show y'all how our code reacts is that we actually put in a negative number. So we put in a negative number for D. So like I said, it's going to go through each element and see if it's a negative number. So after I explain this, you're going to see how our code reacts to negative numbers. You'll also see how it reacts to length AB being greater than length D. So it happens twice, I believe. It happens here, and then it happens again somewhere around here, I believe. Length AB, 25 being greater than 20. Oh, no. Length 21 being greater than 20. So you're going to see it twice, how it reacts. So I'm going to run the code, and it says up here, one or more of your loaded data values are negative. The absolute value of the negative data was taken. Awesome. One or more of your length AB value was larger than its corresponding length D value. Make this value less than 1 and greater than 0.75. Replace the value. This is where we let the user correct the value and put in the correct value. No? So we go over here to our Excel sheet, and we can see that -4 is obviously less than 3.2. So it says make this value less than 0.1 or greater than 0.75. So I'm going to pick 0.85. Again, like I said, we had another value that was incorrect, and it says corresponding length D value. Make this value less than 20 and greater than 17. So replace the value AB. I'm going to choose, again, 18. And here we go. It's going to pull up all 15 different graphs. Like I said before, cable AB is blue, cable BC is green, and our ceiling is black, which is line D. And we have all 15 different trials, as you can see. And then up here are different values. So you have trial number 1 through 15, the thetas for all different trials, the tensions. I'm going to pull it. Oh, no, maybe I can't. Yeah, I can pull it down. So here are all our different tensions AB, tension BC, with respect to their trials and with respect to their lengths of AB. So here are tensions, here are, so here are tensions, and here are our angles that were produced. So I'm going to pull this back up, and here's our last fprintf statement. The maximum length of BC is 8.66 feet. And that's about it. So thank you, and I hope you enjoyed this video.